Flownex provides a complete capability for all your fluid thermal system needs, and one of those capabilities is to perform pressure waves and water hammer analyses. Now, these analyses are very useful in conjunction with pipe stress analysis software, and Flownex has had the capability to calculate the forces due to pressure and velocity changes on all the components, and also to output these in nice, easy formats if you want to use it. So, regardless of what pipe stress uh, software you use, it is able to use Flownex with that as well. We have supported the PCF format for import for a long time, and that's a good way to get the geometry from your pipe stress analysis into Flownex. And you can also, of course, with the reporting, easily get it out in CSV format or something similar. But we had the opportunity to work with the people from ROHR to make this whole process even more seamless and easy to use. So if we go to ROHR, we've got a little example open here, and there now is a export to Flownex option. We click on there, we can export it. Let's just call it model Flownex video and save it. This exports all of the geometry and information that Flownex needs that is available in RAW, and also it exports the required results that must come back from Flownex so that the setup is quite minimal needed in Flownex. I'll just switch to a Flownex project I have open, and if we go to the import tab, you will see there are new ROHR2 items. We click on import ROHR2, and let me just browse to where that file has been exported. And now we can import the Flownex video file. There's some configuration that you can do, but the default setup is actually perfect. We will just import it. And now if you look, you will see it's the same pipeline that as we had in ROHR has now been created in Flownex. Of course, need to do a few small things to get it to solve in Flownex. We need to say what kind of fluid is going to be used in the system. So we just select water as our fluid to be used, and we need to give some boundary conditions. So let me just quickly enter some pressures at all of the ends of the system. And we press solve, and it's as easy as that. We've got a solving complete system that came from ROHR. Now we want to do some water hammer analyses on these. For water hammer, it's important how your pipes are restrained, and it's important what materials are used in them. If the restraint information is available in ROHR, it will be set up automatically. In this case, there was no information, so we will just go and make it expansion joints. You can make it anything else according to how your actual pipes are restrained, but this way we will get a nice, quite elastic pipe system. And all of our pipes are typically made of some kind of metal. We'll just choose a steel, and everything is set up to go. Can just solve it once again, and everything is good. In water hammer cases, it's important that just use quite small time steps. So we'll start with about 10 milliseconds. and we will want to have some kind of graph to show us what is happening in our system. So what we are going to do is we're going to close this valve very abruptly and see the water hammer effects that are happening. The only valve data that is available from ROHR is a secondary loss. So we've modeled that valve as a secondary loss. You can of course replace it with some kind of valve details, but since the secondary loss is the only information we have, we modeled it with the secondary loss component. And we will completely close this component about halfway during our simulation. We just make the graph operate over a smaller time range so we can see everything that happens nicely. And let's put some results on there that we would want to see. Now we can start running our transient. And I'm just going to let it run until about 0.5 seconds. Then I'll pause it, close the valve and see what happens. When I pause it, I'm also going to make the time step even smaller so that we can see all of the details of that pressure wave that comes through. Here I'm closing the valve immediately, and if we run further, we will now see the pressure spike due to the water hammer. And we give it some time for this wave to develop. We can zoom in to see more details, and there we can see a nice water hammer wave. Now as we are approaching our steady state conditions, we can go back to our scheduler and just make our time step longer again and quickly run to the end of our simulation. Just as well stop it now. Here on the import tab of RAW, you will see configure results. This has been imported where our forces have been defined as well as their directions. See the start and the end node that defines the direction of the force, and here is the location of the CSV file that gets written out for RAW. All of this happens automatically. So now we can just switch to RAW and we can go to our load cases setup, go to our water hammer case, and we can import the file that has been created by Flownex. So it's this model Flownex video file. Very easy to import in RAW. Just say which row has the load names, where do we find the first load, and where do we find the first time step. And there we import it. Everything has been imported. Now we solve this case, and after it's done solving, we can go and view the results. What we expect to happen is to see after about half a second some serious deflections in the pipe due to the forces from this water hammer. If we run it, you will see just after 0.5 seconds we get the expected deflections. So as you can see, this is extremely easy to use. You can generate water hammer and pressure wave load cases in a very short amount of time. Also want to say thank you to the guys from ROHR. It has really been a pleasure working with them. They've been extremely responsive and helpful, and this has really been very easy to do with their help. And this is just another powerful tool that forms part of Flownex now to be your complete fluid thermal system solution.